Hi, I'm Doug Black. I'm editor at Inside HPC. And today we're talking with Altair, the provider of software and cloud solutions for simulation, IoT, HPC, data analytics, and AI, and with AMD, which in March announced its new EPYC Milan 7003 series 7-nanometer CPUs. We have with us today two representatives of the companies. We have from Altair, Eric Luckineau, who he is Vice President of RADIOSS Development and Altair Solver HPC, and Kevin Mayo. He is AMD's Director of High Performance Computing Solutions Engineering. Gentlemen, welcome.
Thank you for having us.
Hi, Doug.
So Kevin, let's start with you. We know AMD and Altair have worked together for many years. Tell us about the latest work the two companies are engaged in now, and how the new third-generation EPYC CPU architecture supports data and compute-intensive applications like Altair's.
Thank you again for having us today. Sure. It's been a great time to be at AMD over the last few years, and one of the best things about that from my role is working with great partners like Altair. Eric in particular has been a fantastic person to work with, as has everyone else at Altair. So I want to thank them for that partnership. The EPYC in general came through as a kind of a throughput focused processor. So be it the high core count, be it the high cache, et cetera, and also the high memory channels, it's able to just crank through a lot of data, be it a memory bandwidth intensive application or a compute intensive application, you name it. So all of those characteristics came together exceptionally well running Altair's products. So we've done probably the most work on RADIOSS and AccuSolve, but also working on other applications, and not just tweaking and tuning how they run, but tweaking and tuning how they work internally. So working with Eric and his team on optimizing use of different math routines, et cetera, continuing to get better as we go down that path.
Yeah, that's interesting, because I noticed in your support materials, it appears there's a great deal of flexibility in the types of Altair applications that AMD supports. Tell us about how the two companies work together on this and how you evaluated the recommended EPYC models by workload.
When EPYC came into the market originally, it had certain advantages and areas that we could get better. And so as we've gone through the first generation and the second generation, now the third generation, we've closed those gaps, and in general have very good performance across just about any HPC workload out there. And so what that's allowed us to do, working with folks like Altair, is to take advantage of all of that compute power, all of that throughput capability, as I mentioned, and we've been able to take the standard models that Altair uses, using those as examples. We have large clusters internally that we bring in their applications, we run through their benchmarks, we do performance profiling, analyzing which processors fit best to each application, and not just from a performance standpoint, but from a performance per dollar standpoint, performance per watt, et cetera. So we can take those workloads, really go through a deep analysis, looking at, and I think some of the reference material you mentioned has some of the analysis in there, not just looking at the performance of the product, but trying to find the sweet spot. If you're paying a software license per core, trying to find the best per core performance and balancing that with the overall per node kind of time to solution. So striking that right balance from time to solution to performance per core is important in HPC, and especially on commercial codes. And like I mentioned a couple of times now, Altair's been a great partner to help us optimize that and do great things for the customers.
Yeah, I'm sure customers really appreciate that. So Eric, let's turn to you. From Altair's perspective, talk about some of the key advantages that AMD EPYC chips offer Altair customers using your solvers.
Good question. In fact, since AMD made its comeback in the HPC with its first generation of EPYC processor, we continuously observe tremendous performance improvement running Altair solvers. with the second generation EPYC and now with the third generation EPYC processor. For Altair customers, this means that they have the ability to decrease time to solution using this type of processors. So to address more complex problems, to do more experiments, something very important in the context of optimization of products. So for example, in automotive, to allow to improve both the safety and the CO2 emissions for safer and greener vehicles, thanks to Altair simulation-driven design tools. So more precisely, the good balance between the CPU core performance and the memory bandwidth with the 8 memory channels of the AMD EPYC, together with the increased number of cores per CPU socket, up to 64 cores, are two critical aspects for this performance improvement running Altair simulation solvers.
Okay, great. Thank you. Now looking at specifically at RADIOSS and AccuSolve, talk about the performance characteristics and advantages with EPYC, the new EPYC 7003 series.
So first, just to recall that RADIOSS is our leading analysis solution to evaluate and optimize product performance for highly nonlinear problems under dynamic loadings. It is used worldwide since more than 30 years across many industries, mainly automotive, aerospace, defense, electronics, consumer goods, to improve crashworthiness, safety, and manufacturability of complex designs. And RADIOSS is well known with its very high parallel efficiency, one of the few industrial code aimed to scale up to several thousand of cores, indeed. So here in this study, we focus on two standard models, so frontal car crash models, a small one with 1 million elements, mainly to check a single node performance, and another one of 10 millions of elements, which is representative of today's model at auto OEMs. So well designed to test multi-node scalability, as it is a really compute intensive type of simulation. So here we tested 3 AMD EPYC processors, so the 74F3, the 75F3, and the 7543. So as expected, the 75F3 delivers the best performance thanks to higher number of cores, so 32 cores per socket, and higher CPU frequency. But indeed, the performance gap between the 75F3 and the 7543 is relatively small, around 5–6%. So the 7543 is really interesting to maximize per watt performance. So we also tested the multi-node scalability. So with the 75S3, which shows a very good efficiency with a speed up of 3.86 over 4 nodes. So something around 96+% of efficiency over 256 cores. So then we expanded the test to AccuSolve, which is a part of Altair CFD offer, a comprehensive set of tools to solve fluid mechanics problems. So AccuSolve is our general purpose Navier-Stokes solver. It is massively scalable and benefits from GPU acceleration too. So for AccuSolve, we ran a standard model which simulates an impinging nozzle with more than 7 million of grids using Sparlat-Almaraz turbulence model. Again, we tested 3 types of EPYC processors, the 74F3, 75F3, and 7543. But this type of problem is mostly sensitive to memory bandwidth to solve a linear equation based on flow and turbulence matrices. So what is really key here is rather the 8 memory channel available on the EPYC. So in fact, all the CPU models showed extremely good and comparable performance. And the additional cores do not play a sensitive impact here. However, we plan to test some other CFD workloads which could better benefit from additional core count and better suited for multi-node performance. And to conclude on this study, if one wants to select a common platform for running Altair RADIOSS, AccuSolve, as well as also other solvers like OptiStruct for structural analysis and FECO for electromagnetism, we are confident that a solution based on the EPYC 75F3 or 7543 will be really efficient with a very good compromise between the per-core efficiency, the single-node best performance, and the multi-node scalability.
Okay, great. Great stuff. Great overview. Thank you. So Eric and Kevin, great to be with you today. Best of luck, and I hope you have a great ISC.
Yeah, thanks a lot, Doug.
Thank you very much. Appreciate the time.